Good day, everyone, and welcome to week 4. My name remains Aunduna Moses. I'll be taking you through week 4. First, I would like to congratulate every single one of you that made it this far. I know the journey can be difficult sometimes, so congratulations for making it to week 4. I'll be taking you through data manipulation with Pandas. So far, you've learned Python basics. We looked at functions and we discussed NumPy, right? Previous weeks. This week, we'll take a big step forward. Look at Pandas, how to handle real data, especially your mini capstone projects will have to handle real world data and all of that, right? So most data are going to come in very messy, especially from data set from hospitals or in settings like Africa and all of that. And you're going to get your data set in different type of format. You could get it in CSV format, you could get it in Excel format. And I think some data sets actually comes in PDF format, right? So uh, Pandas allows you to manipulate this data set, clean this data set, and make it ready or ready for any machine learning model to use, right? So it's a tool you're going to use virtually every day, except maybe you're working on imaging. But even imaging, sometimes the pixels are converted and then saved as CSV files that you can then use Pandas to manipulate and load. All right, so welcome to week 4. Right, so one of the most important libraries in the field of data science is Pandas. Almost everyone has to learn Pandas. Right, and the reason being is Pandas gives you that ability to handle any kind of data set. So if you're working in hospital settings, could be patient records, could be scan logs, could be clinical trial data, not like Python. Pandas is your go-to. Right, it is not optional. It is an essential tool that you need to learn when working or beginning your journey into medical AI. Your data almost never comes ready to use. It's one thing you need to get used to. Your data will never come ready to use, right? You get a messy CSV file, right? Sometimes you get data and some names are missing, some ages were not imputed, some values were duplicated, and all of that. Python gives you that tool to let you clean and wrangle all of that into something that your model can learn, because you can't pass that messy data into any model at all. Right, so it allows you to handle real data, which I've talked about. Then you are able to explore, fast, inspect, filter data, sort and do all kinds of things. Then second ability is allows you to clean the messy data. Like I said, your data never comes in ready to use. So you need to handle the missing values, handle the duplicate, and then also clean some of the inconsistent entries that you may find in the data set. And then finally, you're able to analyze and then summarize and present some kind of like descriptive statistics of that data set. So how do you get started? First, you need to install Pandas if you are going to run Pandas locally on your system. So if you're going to run it locally on your system, then you need to install Pandas. How do you install that? Is you use the pip that comes with Python. So pip install Pandas. But if you're going to use platforms like Google, Colab, and Cargo, then Python comes pre-installed in those platforms. You don't need to install Pandas. All you have to do is just to use it. Right, so how do you then use it is to import the modules. Like I said, these are libraries or modules if you want to call them. You have to import them into your code to be able to use them. Now, in Python community, we always use a convention of the alias, which is PD. We say import the name of the module, which is Pandas, and then we say as PD. That means we're importing it. So anyway, you can use PD simply represent Pandas, right? So like I earlier said already, in all both Cargo and Google Colab is it comes pre-installed, so you don't have to install it or anything. Now, if you look at Python, we discuss about lists, we discuss dictionaries and tuples. All of those are data structures that we use in Python. In Pandas, we have two core data structures that are used, and these are the building blocks. These are the building blocks of Pandas. And this series and data frames, right? And the one way to differentiate between them is think of series as a single column, a single column. So imagine you have a table, and in that table, each column is a series, right? And then think of data frame as the entire table as a whole, right? So everything in Pandas built is built around these two, series and data frames. And well, Pandas series, the series, like I said earlier, is basically a single column. So if you look at a spreadsheet, if you're used to spreadsheet, each column in that spreadsheet, you can classify it as is a series, for example. Right. So if you look at an example here of the series we just created, so we import pandas as PD, and then we create a series of tumor size, right? So we say PD, the series, and then we pass in tumor size, we give it a name, right? So if you print it out, one thing you always get with the series is you have the index and then you have the actual values. The index on the left and then the actual values on the right. Like I said, computer, everything starts from zero. So 0, 1 to 4. And then the values is 2.3 and all of that, which are the values that we have here. Right. So, but notice the creation of the series. So PD, which is PD dot series. The S is uppercase. The series open parentheses, and then we pass in the values we want to convert to Panda series. Right. And then we can give it a name. It depends on the column you're dealing with. So you can give it any name. Right. For data frame now, you can think of data frame, like I said, the entire table or like the entire spreadsheet. Right. So you can see the creation, which is PD dot data frame. D is uppercase and the F is uppercase. Then the rest are lowercase. And then we pass in the entire dictionary. So you can say name as a key, then the list as a name, ages, scan type, tumor, and then the diagnosis. So you print it out, you can see you have a complete table that contains different columns. So think about it as each column here now representing a series. The name column is a series, the age column is a series, the scan type is a series, tumor centimeter column is a series, and the diagnosis column is a series. And when you put all of them together, which makes a complete table, that gives you a data frame. Right? What's the difference? The difference is clear, which we've discussed already. Series is one column. Each column is a series. Data frame has multiple columns, right? And then you can think of a series as having a single list with labels, right? Well, the data frame has more like a spreadsheet or the entire table. And then you can access each one. Then think about as each column in the data frame actually represent a series. Right. Now, one thing is creating data like we created the tumor size, centimeter data, and all of that. In real world, you have to know how to load your data into data frames. You need to load your data into data frames. So like we discussed earlier, that the real medical data will come in different files, CSV, Excel, JSON, and SQL, and other format that you may get. You may even get some data set that will come as URL. So how do you load them? To load them, we have some common functions or common methods in Pandas that we use, which is the read underscore CSV, open and close, read underscore Excel, JSON, and SQL. All of these methods are what we use to load data sets into a data frame, right? So an example is here, we import, remember we have to import pandas first as PD, and then we say df equals to pd dot read underscore CSV. In the code, we pass in the name of the file. So in this case, it's patient underscore scan dot CSV. So you need to pass in the name of the file. Right. If it is in URL, you pass in the complete URL in code, still the same thing. In this Excel format, is simply just the same. It's just the name of the method that changed. Right. The CSV have on read underscore CSV with this Excel read underscore 0 and this JSON, almost the same thing. Right. Now, one other mistake that most people tend to use is probably the data set is in a different folder or is in a different directory. So, and you want to load it to Pandas. So what do you do? First, you need to pass in the file path to Pandas to be able to load it into URL. So maybe the file is in your document folder in your desktop. Then to load it here, then you need to pass in maybe desktop slash document slash files, then the name of the file .csv. So you need to pass in the complete path to where the data set actually reside. Right. So when you load your data set into Pandas or into data frame, what's the first thing that you need to do? First, you need to be able to look at the structure of the data set. Right. And we have some three popular commands that we use. Within few seconds, we are able to have an idea of what the data set looks like. And that is .head, .shape, and then .info. So .head will tell you, or will let you see the data in the first 5 rows. Then .shape will let you see how big the data set is. .info will give an idea of the data types of the columns that exist in that data format. So if you use patient, that is the data frame, .head, open and close, can pass in a value in between the parentheses or not. If you don't pass in a value, it's going to give you the first 5 rows. But if you pass in a value, let's say you want to see the first 10 rows, then it's going to be the first 10 rows there. It's going to come up. Right? And then if you say .tail, it's going to give you the last 5 rows. If you pass in a value, then it's going to be the last 3 rows. If you look at the shape will give you a values of rows and column. So for example, here you say 5,5. Simply tells you that it has 5 rows and 5 columns. So the rows first and then the columns second. Now, how do you understand the data set? Is you use the .info. .info will give you a summary of what the data types of each column is. So you may see something like int 64, int 32, anything int, you should automatically know that it refers to a whole number. So things like age, count, right? Then float 64, you already know float represent decimal, right? So decimal. And then object simply represent text and strings. So things like the name, the diagnostics, these are text. And then bool stands for true and true or false. Then date time 64 is simply telling you the column is of date time data type. So we did patient.info here, and then you can see age, you see int 64, scan type. Notice it's text. Remember it is text, object, tumor size, remember is in the decimal point, so you have float, and then diagnosis, which is text, is also object. So have all of that in mind. Now, another feature with Pandas is you can select a particular column. Right? You can select a particular column in the data frame. Right? So you can use a single bracket. Now, if you use a single bracket, note the difference between this. If you use a single bracket, it's going to return a series, right? It's going to return the series, which is a single column, right? It's a single column, index and value. If you use double bracket, that's double square bracket, then it's going to return a data frame, right? Get a difference between the two, right? Because when you start putting things together as maybe like a chain, then the output you're going to get it will be different. So if you're expecting to get, let's say, a data frame as an output and you're using a single bracket, then what you're going to get is going to be, it's not going to be a data frame, but a series. And then if you want a series and then you're using double brackets, then you're going to get something else, right? So if you call patient, for example, and then we use a single bracket, passing the name of the column, right? You can print it out. Or we can use double bracket, like I said. You can see we say patient, one bracket, and then another bracket, and then we pass in the name of the columns we want to select. So any column we want to select here is just pass the name of the column, and uh, Pandas is going to select just that column, and then it's going to print that. So in this case, we only select the name, tumor size, right, in centimeter, and then the diagnosis. Then you can see the output, the name, the tumor size, and then the diagnosis. We ignored the scan type. Right. Another way of selecting using pandas is the loc and the iloc. So one is specific to label base and one is specific to position. Right. So if you want to select some rows and you want to use label base, then you can use the loc. And then if you want to use position based, you can use the I look. So I usually think about it as the I being the index, that's like the location. And then without I, look, that's simply representing the label, right? So for example, if you take patient, for example, and then you say dot I look, remember I index, then you say look, passing 0, that means it's going to select the first row, but counting start from 0 with computers, right? So you get the first row, and then you say dot I look. Remember, you can also pass some range. You can slice so 0 to 3. And remember, the last value is exclusive, right? And that means it's going to get these rows 0, 1, and 2, right? You're going to get 3 rows. Now, this by label, by label now. You can say dot look, and then we say 0, and then the name. So it's going to give us just in the first row, we pick only the first name. We pick only the name, which is pattern. So we pick only one name, name in the first row. And then we can also select a range. So this is 0 to 2, and then we have as this, right? So 0 to 2, and then it's specific to column. So you can see the difference. So I look represents the integer position, right? Index, and then the look use label position. And you can filter. So you can filter data in pandas. So for example, you can see you have, if you want to filter, let's say you want a particular tumor size, let's say we want the ones that are greater than 3.0 centimeters, so we can pass in that. So it's a patient, right? Patient, which is the name of the data frame. And then in the first bracket, we then pass in patient. Though we're trying to select the column. Trying to select the column. To select the column, we say patient tumor centimeter. That's the column. Remember, we're only using this just so that we can have a data frame returned to us, right? So then we say greater than 3.0. When you do this, Pandas automatically recognize that you're trying to compare this particular column with these values, each row, each entry, and then you want a data frame returned as the output, and then we can print that these ones are critical. right? And then MRI scans only, we can also check, or we can use if it's equivalent to only MRI, right? So we check if the scan type is equivalent to MRI, then we assign it to MRI patients and then we can print it out, right? We can use multiple conditions, already things that we've learned, the and, right? The or, which is this, right? So we say patient, square brackets, then we select the diagnosis, but we use open and close parentheses to select the diagnosis, patient diagnosis. If it's equivalent to glioma, then we use and, then we select another, the tumor size if it's greater than 2.0. Then we can assign it to the glioma large variable. Then we can print all of that. You can see the output right there. So you can perform some complex filtering using pandas. Now, you've looked at how to load, looked at how to filter, looked at how to check some informations of a data type and all of that. So next, when you've done all of that, next is, like I said, your data set doesn't always come ready to use. It always come messy. So how do you handle the messy reality of hospital data that you may get? First is being able to detect missing values. Right, you need to be able to detect if there are missing values in data sets that you get. So let's see. So with here, we're taking just an example. We created just dummy data. So we say name as this, and then we say age, and so we were 52, and then we put np dot none. So this simply just represents empty values, right? There's no value assigned there. And then we'll do the same thing in tumor, just for you to see. So how do you find missing values, or how do you detect missing values? You can use all of this to detect missing values. One of the common one is null. So is null will check if there are missing values. And basically it's going to return true, right? True if there are missing values. You also have not null. That means true where they are present. So when you use is null, it's simply going to return true if there are missing values. But what you want to know, or what you're interested in, is how many of those values are missing, right? Which is why you then use the dot sum method to sum, or to count how many true there exist when is null was run. And then dot sum, we then count how many of those true you have, and then return a count of the missing values. That's what it is, right? If you use dot any, it's simply just checking if any values is actually missing, right? So an example which is here, which you use df is null, and then we use dot sum. If you don't use the dot sum, you're going to see true, false, depending if there's a missing value, right? When you use dot sum, it's simply going to sum the count and give you the number of times true appear or false appear. So you can say in age is showing 1, that means we only have one value missing. And then in tumor center, you can say we have one value missing as well. So how do you handle these missing values? There are different ways to handle missing values, right? And one thing you should look at is a key point actually left here is you can perform a drop. That means you drop some of those missing values. But basically there's a rule for that, because remember, if you are dropping data, that means you are deleting an entire data within your data file. Right. So only drop missing data when you have less than 5% of those values missing. So if you have if the values missing are less than contribute, let's say less than 5%, then you can drop it. Right. If the missing data are kind of like in random, you can drop them. Right. Now, if you're not dropping the data, then you fill them with mean or median. Right. You fill them with mean or median. So if this mean or median, if this numeric, then then you can fill it with mean or median, right? So you can fill mean or median when it is not a numeric, right? Then another one is to fill with mode, especially when it is a categorical column. So categorical column simply means if this text is text, for example, the scan type and the diagnostics if it's missing. So let's say example, so they took a scan, right? And let's say the scan type was MRI, but somebody forgot to fill MRI in the scan type. So you can fill that uh, using mode, maybe in the most common in the data. So all of those methods you can use them. So you can say we have DL and your data frame, depending on the name you gave it. So if this DF, if this patient data, anything, so you say drop NA, right? So this will drop any missing value. So if you want to drop the missing values completely, remember it is less than 5%, right? It is less than 5%. And then you can draw a particular subset. So if you say drop NA, within NA, you can say subset equals to, then you pass in the name of the column you want to drop, right? And then option 3, which I've said, you can fill it with mean or median. So we pick the H column and then say dot fill NA, that means fill missing values. Then you should take the H column, calculate the median. That is what it's going to use to fill the value, right? Then you can fill forward. That means look at what is in forward. That's what is before the column or what is before the row, and then fill it up. Or what is after the row and fill it up. That's what I mean by fill forward or backward, right? So, for example, if you look at the tumor size, and then you fill, and then you can decide to fill it with the value before it or the values after it, what method you are trying to use, right? Next is you also have some duplicates in your data set, like I said, which you can remove, or to remove duplicates, or to look at duplicates, to count them. You can say df.duplicated.sum. This will count the number of duplicates that you have. You can drop those duplicates by df. Remember, this df represents data frame. Once you load it and you assign it a particular variable, that variable becomes a data frame. Right? So you can drop the duplicate, remove duplicates if you want, and in a particular subset, you can drop the duplicate, take the subset, right? Then you drop. So now you can rename some columns. Yeah. So sometimes, especially medical data, and yeah, I think especially medical data, most times the naming convention is extremely poor for use in different models. So a column may come like a patient, and you have space and you have name. All of this is going to really affect your model. So we rename it to like name, and then tumor space size, we can rename it, and scan date, name it. You need to have a consistent name. So how do you do that? We have DF, that means everything we do, we then assign it back to the data frame variable. So say df.rename, then we select those columns we want to rename. So columns equals to more of a dictionary format. So the patient name, and there's a column that has something like this, and we rename it as name. And we do the same thing for tumor size and the scan date, right? Then next is data types. Sometimes the data type that come with a particular data set doesn't really match the type of analysis you are trying to create. So age sometimes may come even as text. Yeah, so age may come sometimes as text or strings. So you need to convert it. So we take df age dot as type int. So we'll convert it to an integer because it's int. And scan date, most times date in medical data that I've seen will come as strings. So you need to convert it to date. There's a PD dot to date time. Then we'll pass in so we'll convert it to date. And then we'll convert the tumor size also to a numeric values. Right? So you can add, you can modify a column. So sometimes you may want to create a new column or modify an existing column. You can do all of that. So let's say we want to create patient status as a new variable. And the patient status equals patient, take the tumor size, then we can use the dot apply. And in the apply, we simply just call the lambda function. And then we discuss about the lambda function. So the lambda function simply just takes particular value, let's say x, for example, and then we write a conditional statement if x is greater than 3.0. So it will go through the tumor column. If it's greater than 3.0, then it assigns it as critical. If it's not, then it's set as stable. Doing this is going to create another column referred to as status, right? So you can perform some calculations and then create it as a new column. So you can see patient as centimeter multiplied by 10 to convert it to millimeter, right? And then we can convert the names. So we take the names and then we convert it to upper, right? Can do all of that. Then we want to put some things in category. So you can say we import numpy, keep patient as a priority, np dot where the tumor size is greater than this, then we use high. If it's not, then we put it under the normal category. You can sort data using pandas. There's a patient that sort values. We pass in. When you use ascending equals to first, so it's going to reverse the order of ascending. If it is true, then it's going to give you in ascending order, right? Then you can sort multiple columns if you want. So you can sort columns, you pass in the columns. So if you say ascending true, comma false, Pandas is going to work a way of arranging them into different into ascending and then descending order, as you can see the output here. Now, like I said, when you load your data, you look at the data, you clean your data, change some columns, rename some columns if that's needed or if that's what you want to do. Then next thing to do is to perform a descriptive statistics on the data, more like you are summarizing the data. Now, a Pandas provided with a method that you can use, which is dot describe. Right, so if you call your data frame and you say dot describe, it's going to give you a particular information which you're seeing here as the output. So let me explain it. Short, so if you see count, it tells you how many null values are in your data. Mean is telling you about the average mean, standard deviation, mean max, that 25%, 25% percentile, that's Q1. 50% telling the median value, and 75% tells you about the 75 percentile in the Q3, right? So all of that is, you can look at individual statistics if you want, just like when we discussed NumPy, we did dot mean, dot max, standard deviation, and all of that. You can do that in Pandas as well. Pandas as well, dot mean, you can take a particular column, dot mean, dot median, dot mode, access the first, check the standard deviation, check the variance, check the mean, check the max, check the sum. You can do all of this within one line, which Pandas is going to allow you to do. And then you can group some data by applying things like split and combine if you want. So you can say patient, the group by, you pick a particular, so we say diagnostics, and then we pick the column, and then we simply just get the mean. So the mean of the diagnostics that was carried out. We can look at the scan type, right? And then we'll look at the aggregate, both on the age and then the tumor size as well, right? So you end up with glioma 2.9, meningioma this, normal, this as well, right? Then you can perform some correlation. Correlation analysis, for some of you that don't know, so correlation could be positive, could be negative, or there could be no correlation. So when you talk of correlation, you're trying to compare two things, right? So if it is positive, if it's close, very close to one, positive, then we say it has a positive correlation. And then if it is negative and it's close to one, and this is a perfect negative correlation. Remember, it runs from 0 to 1. So you could have 0 0.8, 0 0.2, 0 0.3, depending on what you're comparing. So the closest it is to 1, it simply tells you that there's a close relationship between those two variables, right? So an example, we're trying to compare age and tumor, then we say dot core, that's dot correlation, right? So if you look at it, you can see now sometimes it prints these values, but the diagonal, so look at this, the diagonal is not included, right? The diagonal is not included because the diagonal is simply comparing the value with itself. So the one you need are the values here. So you can see here you have 0.72. This is a strong positive correlation between age and tumor size. And here you can see 0.72 is a strong positive correlation between age and tumor size. So simply it's telling you that the older the patient tends to have a larger tumor size, right? So that's correlation for it. Then when you do all of that, you can put everything together. So first, like I said, you load your data by using PD underscore read underscore CSV. So you load the data, you exploit the data by looking at the shape, look at the info, look at the head, you can check the tail, then you clean the data, right? These are the steps, clean the data. So you can drop empty values if you want. You can drop some duplicate values if you want, or you can fill some of those empty values with these values depending on how you looked at the data, right? Then you can analyze by group using group by to look at some values. Then you can filter some of those values out, and then you yeah, and then you are done with your analysis. Right? Next, or the last step you need to do is to save your work. So you've cleaned the data and performed different analysis. At least once you have the clean data, next you save the data so that you can use the clean data in your in your project, right? So to save data is simple. Just call the data frame dots to CSV, depending on the file format you want to save it. So you can save it as CSV, that's two underscore CSV, and then you pass in the name you want to save it as. Right? When you say index first, it simply means you don't want it to save the index. Right? You don't want to add the index as part of the data you're trying to save. You can do that as to CSV, all of that. Right? Or you can save it, but a specific subset of a data set by accessing this data greater than 2.0, and you can save them. Right? So you have some common pandas errors that you're going to come across. So I've left them in the slide so that you can read through and see how it looks like. Then I've dropped you a pandas cheat sheet that you should go through. So things like loading your data set, checking the shape, and all of this. You can see you have access to this slide to look at everything. Then you have some bonus string operation that you can go through. How do you practice? Simple. Open a Google Notebook, load some data, try real data set. Just break things if you can. There's no specific way, right? And then build a mini project if you want. And then yeah.